This video will be about the graphs of sine and cosine. So for the first part, we will try to get an idea of how to graph these. So the first part, whenever we're finding these values of 0, pi, pi over 2, 3 pi over 2, and 2 pi, we need to remember back to where we had our xy axis. And on that we had over here at 0 and 2 pi, we had the ordered pair of 1, 0. And then up here at pi over 2, we had 0, 1. Back here at pi, we had negative 1, 0. At the bottom, we had 3 pi over 2. And that was at 0, negative 1. Now, when we talk about y equals sine of x, that's talking about your y coordinate was sine of x, or sine of the angle theta. So that is going to tell me that my values that I'm looking for around the xy axis is going to be your y coordinate. So whenever we're looking to get values to plot, whenever we start out at 0, well, at 0 the y coordinate is 0. At pi over 2 the y coordinate is 1. At pi it is 0. Again, we're looking at the y coordinates here. That's where these are coming from. So the next y coordinate would be negative 1. And then back up again at 2 pi. So you draw a smooth curve through these. And make sure you have your arrows on each end. And there's the graph of sine of x. Now, when we talk about the domain of this graph, you're talking about how far left to how far right you're going to go. So that's going to be from negative infinity to positive infinity. Your range is how far below to how far above. And so that's going to be from negative 1 to 1. Your x-intercepts are occurring at 0 and then 1 pi at 2 pi, and then it would occur at 3 pi and 4 pi. So your x-intercepts is going to be at some value k times pi, where k is an element of integers, where k is some integer there. Your y-intercept is at 0, 0. Your maximum value is 1. Your minimum value is negative 1. This function is continuous, and it is bounded above and bounded below. And then this function is odd because if you rotate it about the origin, so it's symmetric about the origin, you get the same graph. So do keep that in mind. And then your key points that you need to know would be 0, pi over 2, pi, 3 pi over 2, 2 pi, and then plus or minus 1. Those are your key points. Now we're going to graph cosine, and we're going to see that it's very similar. We're going to go through the same idea here. We're going to pull back out, same xy axis, and we're still going to look at our points 1, 0 at 0 pi and 2 pi. Up here we have 1, 0, that's at pi over 2. Back over here we have negative 1, 0, that's at pi. Down here, 3 pi over 2, and then that's going to be 0, negative 1. But this time we're looking at cosine of x. So cosine of x is your x coordinate. So x equals cosine of theta. And that's going to be the x part. So, or your x coordinate. So going around through here, we're going to be picking off your x. Let's make that 0, 1. Sorry, guys. So you're picking off these x values through here. So at 0, then your x coordinate is at 1. At pi over 2, you're at 0. At pi, -1. 3 pi over 2, 0. And at 2 pi, you're back around at 1. So now let's go through and connect these, and do connect them with a smooth curve. And make sure you have arrows on the ends of your curves. Now, again, answer your questions. Your domain is from -infinity to +infinity. Your range is from -1 to +1. Your x-intercepts, now this time, it's a little bit different. We're going from pi over 2 to 3 pi over 2, so the next one would be 5 pi over 2. Then the next one's 7 pi over 2. So it looks like we're adding a 2 pi over 2 each time, which is just pi. So we're going to say x-intercepts, let's erase that. That's going to be pi over 2 plus some integer value times pi. And again, k is going to be an element of the integers. Your y-intercept occurs at 0, 1. Your maximum value is 1 and your minimum value is -1. This is continuous and bounded above and bounded below. And your symmetry, this one is even. If you continue this out, it would be a mirror image of itself about the y-axis. So it's symmetric about the y-axis. And its key points are 0, pi over 2, pi, 3 pi over 2, 2 pi, and plus or minus 1. So those are important for you to remember. All right, now when we talk about amplitude, we're talking about changing the boundaries of our sine and cosine curves. We're talking about how tall the curve is or how short the curve is. So we can change that by just multiplying our curve by a number. So notice where the number has to be. We have a number here and a number here. And we can see what happens. Let's start at 0. Pi always starts, or sine starts at 0, and it was at 0, 0. But then that's going to be times 2. Well, 2 times 0 is still 0. Didn't show us a whole lot there. So let's go to pi over 2. Well, sine of pi over 2, that gave us 1. But this time, we're going to have that 1 times 2, so it's going to be 2. And then at pi, sine of pi was 0. And then 0 times 2 is still 0. 3 pi over 2 was -1, but we're multiplying by this 2 here, so that's going to give me -2. And then back around at 2 pi is 0. So again, connect your dots with a nice curve and put your arrows on it. And then with the -2, we're also going to change the amplitude, but we're also going to flip over our cosine curve. So let's keep in mind where we started at. At 0, we were at 1, but then we're going to multiply that by -2, so we're going to start way down here. Then pi over 2, we were at 0. Then pi, we were at -1, but we're going to multiply that by -2, so that's going to put me at a +2. And then we were back at 0, and then we'll be back at a -2 again. So here comes our curve, the best I can draw it. Okay, so notice what happened this time. The graph got flipped over. It's a cosine curve, but it is flipped over, and we changed our amplitude. It was all the way up here at 2. So in both examples, the amplitude is 2. In general, we can say that a sine bx or a cosine bx, then the amplitude is defined to be the absolute value of a. That is something you need to remember. Okay, so talking about the period of the function, that's how long it's stretched out. So here, for example, for a, the graph of this, example 2, this is going to be what you have known as a shrink. And that's because our graph is going to shrink up a little bit. And notice here again, pi over 2. This is going to put that 2, our graph is going to change a bit. And here we're going to have our 1. It's going to shove everything back and make our cycle of pi over 2 is going to go through twice as fast. So our graph is going to go through twice as fast as what it usually does. So I'm plotting in our points. So everything, I think I put that -2 too far down. It should have been at -1. Let me go back and fix that. This should be at -1. Sorry, guys. So notice how quickly, and of course we're at 0. This goes through, and we'll work on getting those signs. Oops. Or those points here. We're just seeing that this is a shrink. We went through twice as fast. In other words, we've repeated this curve twice. There's once, and then here's twice. So that's why I'm saying this goes through twice as fast. Now this one's going to go half as fast, so it's going to be stretched out. So this is going to be a stretch. And when we look at that curve, again we have here 0, 1, but then we're stretched out to pi, and then stretched out to 2 pi. And really, for one period, that's all we see of it. But then we can continue on to 3 pi and then 4 pi to get the rest of it. And that would be here, it's only repeated itself once by the time it gets to 4 pi, or it's taken it half as long to get through. So that is your stretch. So you can describe what happened to the graphs. Can you describe? And then the periods for each of the functions, you're going to say is 2 pi over b. And because one full cycle can be graphed in the interval. In general, we could say that a sine bx or a cosine bx, right there is where you can find the period. And compare and contrast, if b is greater than 1, then to when b is between 1 and 0. Okay, so if b is greater than 1, you have a horizontal shrink. Pen stopped working there. And if between 0 and 1, you have a horizontal stretch. And that's talking about the b value, that denominator there. So b you can think of as the coefficient of x. So the coefficient here would have been 1/2 x, which is between 0 and 1. All right, a full phase shift, we'll do those. We'll get there tomorrow. So it's not going to be on this video here.